want to spend whatever time we need going through 510. Which ones on there can I go through, explain, whatever? Yeah. Number 10. Same one? Okay. We should probably do number 10 then. Power station. Power station. River is 0.5. 6 miles downstream is a factory. Okay. So the idea is that if you run this power line over land, it's cheaper. But if you want to go directly across, now you're going to have to go longer. Well, this would be underwater, I guess, right? And over land. So, we could go straight across and then down. We could go all the way. Well, that's the same. We could do a diagonal line, but then you're underwater the whole time, so that's more expensive. The idea is which way is going to get me there the cheapest. So I'm just doing this kind of for myself. Land is 60K per mile, and underwater is 85K per mile. Okay. So you are going to do that. We just don't know exactly where this point is. It might be straight across it comes out. It might be that this point is down here and your diagonal line goes like this. It might be that you go all the way. But we're going from here to here. I know that this distance is 6. So if I call this distance x, here to here, what's this distance? So I got x, 6 minus x. I'm trying to get from there to there. Okay, this is 0.5, right? So what is this side? Squared. That's Pythagorean theorem, right? So this side would be the square root of 0.5 squared plus x squared. And that is me going underwater. So whatever that distance is, it's going to cost me 85,000 times that distance. I don't know the distance because I don't know what x is. X might be 6, and we're just going straight up diagonal. X might be 0, and we're going straight across and then straight down. But whatever x is, this distance will be the hypotenuse of the Pythagorean theorem, and then it costs 85,000 per mile for that tubing or whatever power lines. And then once I get to the other side, how far do I have to go from where I was to the factory? Is your 6 minus x. And how much does that cost per mile? Is 60,000. Oh, they kind of got it for. I didn't even notice that. On land cost, distance on land. So this is the on land cost. I did it backwards than them, but this is the distance on land. This is the distance on underwater. This is the cost underwater. So, I know that was probably in the. Did he do it the same way that I just explained it in the notes? So that was in the notes. notes too, so is that helpful? Does this help you tell what's going on? Okay. Izzy, are you good? Okay. There are other people that are asking about 10. Yeah, let me finish up with this. Is that okay for 10? Okay, you said 11? Like, I don't mind if we end up doing that. Okay, so we got this is x, this is x, this is y. The area, so I'm trying to make the area a maximum. So the area of any rectangle is length times width, right? So what is the length of that rectangle? It's 2x because it's just like all the way across, and the width is y. So I'm almost there. I've got my derivative. I've got my equation set up that I will take the derivative of, but it's got two variables in it. So I have to fix that. So that's what this is for. I've got 200 feet of fencing. How many x's would I have to put down to enclose that area? Which are the y's? How many y's are there? 1, 2, 3. How many y's? Or how many x's? 4. So 1, 2, 3, 4. So that tells me that 4x plus 3y has to equal 200 because I've only got 200 feet of fencing. So that's just kind of measuring like all the distances around. And then you're going to solve for one of their variables. I'd probably solve for y. It's just easier to plug into y than it is to like x with a 2 in front. Although it's not that big a deal. But if I solve this for y, I'd have like 3y equals 200 minus 4x. So then y is 200 minus 4x divided by 3, and then I just shove that in there. And for that day, we're good. Does that help out? Anything else on 11? Alright, what else? 6. Did I erase 11 yet, or is that one still written down? You look like you're good. You're good? Yeah, you good? Rectangular pages contain 24 square inches of print. There's margins on the top and bottom. So let's say I call this x and this y. What do I know is true about? What equation can I make out of that, and what's given? Still not sure. That's a very good question. What I'm trying to say is it's supposed to contain 24 square inches of print. So it must be true that like x times y equals 24. That's the area that you're printing. That makes sense. And then there's a top and bottom border of 1.5 inches. So you'll have a border around the outside. This is 1.5. This is 1.5. So the overall length isn't just y, it's y plus 3, because you got 1.5 on either side. Same idea with the x's. It says there's a 1 inch border, right? On the left and right. So this width isn't really just x anymore, it's x plus 1 more. So it's x plus 2. With me so far? I don't remember what I said. Okay. I'm trying to use the least amount of paper. That makes sense. Like the cheapest amount, right? So I want the area to be a minimum, to be as small as possible. Well, the area of a rectangle is length times width. And I know the length of the width here, so the length is y plus 3. And the width is x plus 2. And so I'm almost there. would say I've done the hard part probably, but I've still got two variables. So I have to do some things to substitute so I don't have two variables anymore. And this is the equation I would use. I know x times y equals 24. So, for example, I can say that means y equals 24 over x, right? I just divide both sides by x. So the area, in terms of one variable, would be 24 over x plus 3 times x plus 2. And then that's where you would stop for yesterday. Like eventually we'll keep going, but that would be the setup. You have what you're trying to minimize, and you have it in terms of one variable. Right around that. So what else? Yeah. 3. Is this one okay? Can I erase? Open box having a square base and a surface area of 108 square inches. Not sure I can draw this, but I'll try. So it's a square bottom, but it doesn't say the sides are squares, so those can be rectangles. Something like that. I know. Two things. I gotta first of all find like what I'm trying to maximize or minimize. I'm trying to maximize the volume. The fact that it doesn't have a lid on it, it's open at the top, it doesn't change the volume, right? So what's the volume of the box? Length times width times height. So, okay. Separately, I know that the surface area is 108 square inches. So what's the surface area of this? Well, the bottom is x, then the area of that like bottom square is x squared, right? X by x is x squared. If I call the top, like the side y, then the area of this guy is what? Like the front face is x times y, right? But how many of those are there? There's 4. You got the front, the back, and the two sides. So what that tells me is x squared plus 4x equals 108. Or, sorry. Yeah, what did I do wrong? Please come on. Yeah, what am I missing? Missing a y, so it's 4xy. Alright, so volume, going back to volume now, length times width times height. Length and width are both x, but the height is y. And that's what I'm trying to maximize. Like I want to use my paper, or whatever I have here, efficiently so I can get as much in this box as possible. So this is the equation I want to eventually work with, but the problem is it has two variables. So I'm going to solve that for y, and then stick it in place. So I would say like 4xy equals 108 minus x squared, and then divide by 4x. So y will be 108 minus x squared over 4x, and then you just put it in place of the y. Questions on that one? Other ones? How do you look like you? Yeah, sorry. No, go ahead. Which one? I'll do it. Number 9. So we're trying to use the minimum material. We're trying to make this as small as possible. I want the surface area to be as small as possible. So I want that to be minimum. So I'm good. Like this is what I want to minimize, but the problem is it has two variables. So they gave me that the volume is 512. They gave me the formula for volume, so I know 512 equals pi r squared h. So then I can use that to find out what h is. So h is going to be 512 over pi r squared. And that will just go in that spot there. And then you have all r's in there. All right, let's go to 511. And get your calculators out. Actually, that's a lie. Don't. You won't be allowed a calculator on your next test, so I can't give you any of the questions that result in like crazy answers or crazy derivatives, which is good news for you. So like this problem we did yesterday, I'm never going to put that on the test and have you solve it because the setting the derivative of this equal to 0 is like a 15-minute ordeal. I could give you this question and say just set it up, but I wouldn't make you solve it. That's the wire one. We have like this type of thing. So you might have to set that up. You will not have to solve it. So now I'm not going to solve it today. But one we can solve. So remember yesterday we talked about, okay, that's the point 5 comma 0. Somewhere over here is the point that is closest. And we said, okay, that's x comma y. But we could do better because we don't want that y in there. We want to use just one variable. So what can I put to represent y instead of putting y? It's the square root of x because they tell me those are equal. So I could look at this coordinate as x comma square root of x. And we did the distance formula, which was the square root of x minus 0 squared. That's y2 minus y1 over x minus 5 squared. Or not over, but plus x minus 5 squared. And my job is to take the derivative of that. So I'm going to go to the next. I need like a blank page. Can I move on to the next? I just need like scrap page. So I want to work here. So d equals, so it's like square root of x squared plus, was it x minus 5 or 5 minus x? X minus 5. So it's like that. That's the equation I'm supposed to work with. Like I took the minus 0 away. Actually, what's the square root of x squared? So it's probably easier if I just call it that. And I can like clean up the inside a little bit even. So that's x plus, well that's just x squared minus 10x plus 25. So then I have x squared minus 9x plus 25. Which doesn't factor. And that's all the 1/2 power. And this is equal to, I'm trying to maximize this or minimize this? Minimize. I want this as small as possible. So what level tells us what to do? Yeah.
Why can't you separate the root into the x and the x minus 5 squared terms?
Like distribute the root?
Yeah.
So here's what, I'm going to be honest with you, I don't know. But I'm gonna look. So I didn't remember when I was in high school. I wouldn't know that. I wouldn't remember the rule. So I would just check. I would just like make up numbers and like, does this rule work or not? Give me a second. Hey, what's up? Yeah, can it be in a little while? Okay. Thanks. see Mr. Jackson after Will. So I think you're saying like if I had like 9 plus 16 to the 1/2, I think you're saying isn't that the same thing as 9 to the 1/2 plus 16 to the 1/2? Or you're asking? I think you see now that it's not. But so what should this be? 25 to the 1/2 is 5, and if I distribute the powers, I'll get 3 plus 4 is 9. So like that's the best answer I can give you. Is just look at that. Yeah. Okay, so I'm trying to find the minimum. What level tells us about minimums? What level tells us increasing, decreasing, relative max, relative min? All 4 of those. First derivative, right? So we need to find the first derivative. So I'm taking the derivative of this. So that's going to be chain rule. 1/2 x squared minus 9x plus 25 to the negative 1/2 times chain rule, right? Times what? 2x minus 9. And then I don't know what the minimum value is, but I know that that's a number. So this just represents like the smallest distance between that point and the line. It's a number. I just don't know what it is. What's the derivative of any number? 0. And our job is to solve that. It's not as bad as it looks. It's not even close to as bad as it looks. If you rewrite it, on top you have 2x minus 9. On the bottom you have 2 times this stuff to the 1/2 power. But if a fraction is going to equal 0, all we need is for the top to equal 0. Because what's 0 divided by anything? 0. Yeah. So what I'm saying is this part doesn't even matter. Because if the top part's 0, the whole thing's 0. So that just kills like all the scary part. So your job is to solve 2x minus 9 equals 0, which will give you 4.5. So like that looks like a crap ton of work, but at the end of the day, like this is really all we're trying to solve, which is fighting through to get there, I guess. Questions on this? I'm gonna go back to the previous page. What's up? Like it's not that bad if I'm not explaining it as I go. They don't take as long as it seems like. But I don't know. It is what it is. I can't make it that annoying. So yeah, I'm not done. This says what point? So I think Hobbes is about to get us there. So 4.5 is the x value of the point. So it's right there. How do I find the y value of the point? Yeah, it's the square root of 4.5. You'll plug it back in. So you could literally just leave it like that. You could go back to the calculator and find out what is the square root of 4.5. So that's the point that would be closest. That is probably the most common kind you will see on an AP test. That is, I think, what's most common in the packet, in the book. That is what is probably most likely to be asked in your test. I think that distance one is one you should definitely know. Questions on it? And you get to practice more. It's not the only one. All right, let's look at 3. 3 is a little bit. Got a little bit of add-on to it. So they give me a position. They're saying on the interval 3 to 9, find when a particle is furthest to the right. So we always talk about like to the right is positive, to the left is negative. So if I'm asking when it's furthest to the right, I'm asking for a max. Like when is it the biggest positive number? When is it as far to the right as it's going to get? So the nice thing about these is I already have my formula. I want this distance to equal max, to be as big as possible. I've already got one variable. I don't have to worry about plugging anything else in, making a drawing, figuring anything else out. I've got my one variable, so what level do I need to get derivative. So the velocity is 3t squared minus 30t plus 72. I'm going to have to factor that. So I can take a 3 out. Let's try that first. T squared minus 10t plus 24. And I forgot to put the n. What is this equal to? It's equal to 0 because I don't know what the max is, but I know it's a number. The derivative of whatever number is 0. And I can factor this. Thank you. So that'd be t minus 6, t minus 4. Agreed? So then what are my two solutions? T equals 6 and t equals 4. So t equals 6 and t equals 4 represent points where the particle potentially turns around, goes back and forth. But the max and min could also happen at endpoints. So like imagine you got a point here, your function's decreasing the whole time. Where's the max? Like at the beginning, right? Or where's the min would be at the end. So we have to check any critical points that we get. And we have to check endpoints. And you're literally just checking. So I've got 4 comma something, I've got 6 comma something. I got those because they're critical points. But I've also got 3 comma something and 9 comma something because those are endpoints. So you have to check both types. What's up? They don't give very much space. So now our job is to plug these numbers back into that top equation. You guys plug in 4 over here. This row plug in 6. This row plug in 3. You guys plug in 9. Let me just share with you. It goes into the original. We're trying to find like the distance. Like when is it farthest to the right? What position? So we plug into the position. $7.29.
Are you confident with that?
Yeah.
Okay.
But like doing that in my head with 9.
That's right.
I know the cube part is right, but I don't know like
What's
15 times 81. 4,000. See, this is where I'm starting to get not so confident. So, just so to ease your mind, if I put a question like this on the test, which is pretty likely, it won't be numbers that big that you can't do without a calculator. It'll be like t cubed minus 4t squared or something, you know, like things that you can do in your head. Who that? Everybody have 4? Plug it in. Does anybody have 6? I'm pretty sure that's right. I know they're all like around 100. I think that's right. You just weren't sure. 3? 20? That's too small. What about 9? Nobody's got 3? Wait, but you all got 27. I got 90 then.
Yeah, that's what I got. So I got 200.
Why did you say 200? Yeah. Alright, here's the. I don't really care, to be honest. I can care if you guys want, but I'm pretty sure you can figure out how to punch numbers in your calculator. The point is, like, what do we do now? So what we do now is when is it furthest to the right is literally just the biggest y value. So that is the furthest that it gets to the right. When does that happen? At t equals 9. So the answer to all that is t equals And these numbers might not necessarily be right. I think they are, but even if they're not, like it's still the same idea. Critical points in this case didn't matter, so it feels like a waste of time. But on the AP test, you get points for like considering them. So you get points for like writing down what we had, and even though it didn't end up mattering, it matters for points. That helps. Other questions on that? Let's do part B. So I'm going to worry about the speed part at the very end. So right now we're just going to roll with velocity. I will address the speed part, but you don't need to worry about it yet. So I want this to be as big as possible. So it's got one variable in it. So I'm good to start with my derivative process. But what level tells us max is? The derivative, right? So 6t minus 30. And I don't know what the max is. I know it's a number. What's the derivative of any number? 0. And if I solve that, I get t equals 5. So how many candidates do I have that this for time? It's 3. That one and one other one. 3 and 9, the 2 endpoints. So I've got to check 3, 5, and 9. And we're plugging back into this, because this is what we're trying to maximize. I think that's 9. I think that's negative 3. You guys have calculators, check me. Is it 45? Seems too big. Did you get the same thing for the first two? Can someone confirm? Okay. Question on what I'm doing up to this point. Hopefully this feels more straightforward than like the one we were doing that you said was like annoying. I think these are more straightforward. Take the derivative, check your endpoints and critical points. Now I'm going to look at the speed though. It says find the maximum speed, and it actually won't make a difference. But what's the speed here? 9. What's the speed here? Not negative. Speed can't be negative. So the speed here is actually 3. It won't matter because that's still smaller than 45, but just remember speed has to be a positive number. So what is the particle? So this is our max. What is the particle's maximum speed? 45 centimeters per second. When does it happen? At t equals 9. So it depends how they ask the question, which one you tell them. Questions on that? Alright. I think 1 through 4 are questions like the one we just did. Remember right? No, I know what you mean. I know 5 is like the. I know what you mean. Yeah. I want you to try 1 through 4. That's it for tomorrow, 1 through 4. And then tomorrow we'll spend more time on it.